People are influenced by lots of things. It seems to be an unproblematic statement. And in this particular video, we're going to have a look at some aspects of that in terms of what influences us. Start off first of all with a question. Genuinely, please do write down an answer to this and put it down on paper, because at the end of this talk, I'll ask you then to re-answer the question and just to see if you think there's any particular difference in terms of your answers. I've got two questions. They're both concerned with the idea of influence. And by influence, we're talking here about how difficult it is to influence people so that they are more likely to favour one outcome over another, or one choice over another. And I've got two questions. First one is, how easily are people in general, the average person, how easily are they influenced? And we have a scale between 0 to 1, where if somebody is in the 0, it's impossible. Nobody is influenced. It's impossible to influence people. It's 1, it means that it's certain. No matter what you do, you can influence people really, really easily. And it's sort of, let's say 0.5 means, well, you might be able to, you might not. Just whereabouts do you think people in general fit into that scale? The second question is about you as an individual. So, we've got an average, a mean for our population, all people. What about you? Do you think that you are more or less easily influenced than the average person? So, scribble them down. Just write them down. There's no right or wrong answer to this here. It's just whatever you feel is most appropriate. Let's have a look at some experiments then have been done around this. So this is going back to 1974, where we have Kahneman, we have Tversky. They took two groups of high school students and they gave them a mathematical question. So each group had one mathematical question. Thing is, they only had 5 seconds in which to answer this. So they weren't able to solve it fully, so they had to really estimate what the answer was going to be. That was the purposeful design, to get people to estimate. The first group, they were asked to solve 1 times 2 times 3 times 4 all the way up to times 8. The second group, they were asked to solve 8 times 7 times 6 times 5 all the way down to 1. Now, obviously, the answer is the same for both of those overall expressions. The value is just over 40,000. What was interesting was the differences between the two groups. So the first group, who were doing 1 times 2 times 3, their guess was about 512. That was the median. If you take all the people, pick the one in the middle, 512 was half above, half below. You take the second group, who were doing 8 times 7 times 6, their median guess was 2,250. So it was significantly above this. Now, the reason for that is what's due to known as the anchoring bias. Now, the anchoring bias is a type of cognitive bias, so it affects how we think, where an initial piece of information, something I give you at the start, is known as the anchor. That affects your subsequent thought process, and particularly it unduly affects, it has more emphasis on it than we would probably want it to have, but has quite a strong influence then on how you think beyond that point. And once you set an anchor, it means that things that we're estimating, for example the maths, or the decisions that we do, or how we negotiate, they're all conducted relative to that anchor. So these are relative measures. And worryingly, but also quite true, if you have any aspects then that agree with the anchor, in terms of, say, its strength, its magnitude, its value, those things, we tend to think, oh, that's good, that must be right, it strengthens our anchoring effect. Whereas if we have anything that doesn't agree with our initial anchor, we're actually more likely to dismiss that or say, oh, that's really not important. So in terms of the mathematical example that we had, the reason it came about is that the groups that were doing 1 times 2 times 3, they were getting off to a small number. So they estimated then the overall 1 as a small number, or relatively smaller. Whereas other group doing 8 times 7 times 6, they had a bigger number, so their estimate then was bigger itself. Anchoring is incredibly commonly used. It is used everywhere, in particular in marketing. It's things that we are exposed to every single day, and it's things that all of us have seen. And I've got 3 examples here of anchoring taken from different sort of courses. So commonly we have it when we are displaying a discounted price. We put the original bigger price next to it. So for example, a garment that was originally $80 or 80 euros is now only 15. Oh, that's a super saving in price. And that 80 gives us the initial anchor that we interpret the other value, $14.99, against. Providing suggested values is another example, and we see this over on the right hand side, where if we want to set up a particular contribution, we can see here we are providing a few suggested values, and we're highlighting one as sort of 10 say dollars or 10 euros a particular month. So in this particular case, that serves as the anchor, and we might pick a value that's slightly less or slightly more than that, but we have established our anchor point. The next one we see is listing the most expensive option first. And we have that then down at the bottom, where we have, for example, our premium, our standards, and our essentials. So over here, the premium is a ridiculous price, $299 a month. But you then compare that, and it's highlighted, so that's the thing you see first of all. It establishes the anchor. And next to it, you have standard $14.99. $14.99, my goodness, that seems a bargain, doesn't it, in comparison to the $300 ridiculous initial anchor that was set. So anchors are very, very commonly used. But here's where it gets interesting, because in the previous example, you can sort of think, yeah, it makes sense, it's marketing. We also are influenced by irrelevant anchors. Irrelevant in the sense of what we think that shouldn't influence our decision. That's no bearing, it's not related to what we're looking at. Let's give you a few examples of that. So this is an experiment done by Wansing, 1998. Quite an interesting one. It was based around selling cans of tomato soup, where went to an actual store, set up a stall, so it was done with real people just buying those cans of tomato soup. And there was a modest price reduction in terms of when you bought them, you saved a little bit of money. But the variable they modified and changed in it was what was the maximum number of cans you could actually purchase. So in some days when they ran the experiment, you were not allowed to purchase more than 4 cans. In other days, you could not purchase more than 12 cans. And in some other days, it was unlimited. You can purchase as many as you want at that slightly discounted price. Now, normal economic theory would kind of suggest then that if something is of particularly high value, you're going to restrict the supply of it. So when it was at a maximum of 4, you would go, oh, that must be a really, really good deal because they don't want people taking more than 4. So maybe that's going to sell more. Whereas it's 12, you think 12, it can't be that valuable. Certainly the 4 should be more attractive. It's more important in terms of the saving. And if it's unlimited, well, is it really a good bargain if you can buy as many as you want? What was interesting then was the actual effects that they saw. And you can see this down at the table in the bottom. So when we had no limit, you can buy as many as you want. We had a total of 3.3 was the average number of cans that were purchased, and the total sold in the day was 71 cans. Fair enough, that's our baseline. When we said a maximum of 4, so it's a really good deal, you can only get 4 of them. The average number of cans went up to 3.6, so it was having a beneficial effect. That's great. And we had more buyers as well, so 109 cans were then sold in the day. So that's really positive. That's good. It shows the benefit of sort of restricting that supply in terms of people thinking that's a better deal. But what happened when they used the maximum of 12? In that case, the average number of cans sold was 7, more or less twice what we've seen in the other examples, and 188 was sold during the day. So in that particular case, 12 served as an anchor, and 12 is a ridiculous number. And people thought, well, I'm not going to buy 12 cans of soup. How many might I get? Because 12 was the anchor, they would pick a value less than that. They might think, oh, I'll go for 6 or I'll go for 8. It meant then that where they reduced to from the 12 was still significantly above the 4. So that's an irrelevant anchor, something that we think shouldn't affect our decisions, but can and does affect. What about this fine bottle of wine that you can see here? Early run some experiments back 2003, and before estimating the value of the wine, they were asked an irrelevant question. So it was in America. They were asked to recall the last 2 digits of their social security number. So that might be, could be 23, it could be 78, just depends on the individual. Now, after they've done that, so just a random question, last 2 digits of social security number. Oh, here's a bottle of wine. How much would you be willing to pay for that wine? So that truly is an irrelevant anchor. It was something that's not related to the question they were then asked. But this is where it gets interesting. So those in the lowest quintile, so it means if you take all of the people they asked and you take the fifth of people with the lowest social security last 2 digits, they were willing to offer an average $8.64 for the bottle of wine. Whereas you go for the highest quintile, so those with the highest last 2 digits, the top 20% for the last 2 digits of social security number, they were willing to offer an average $27.91. So a very significant difference, because those that were calling 16 and 8 and 22 arrived at a different estimated price than those who were doing, well, last 2 digit my social security number are 89, 74 and so on. So that really is an example of an irrelevant anchor, something that we think that surely wouldn't affect the decision that we would make, but it does. Final example then. This is done by John Barra, 1986. Really, really interesting one. So brought people into a room and give them sets of words and were asked to unscramble those words into a meaningful sentence. So you might be given a set of words, she, Belfast, lives in, and you would unscramble that to she lives in Belfast. Now, where it gets interesting for the experiment is that for some people, they were giving words that contained, or sets of words that contained some words associated with being old. Things like being retired or elderly. That was the words that were mixed into the sentence they were restructuring. Whereas for another group of people going through the experiment, they were given youthful words in terms of being young, youthful, energetic, and things like that. So they went in, they sorted a number of the different sentences. That was fair enough. Then the experiment actually began. After that, from the point of view of the participants, the experiment was done, and they said, okay, thank you very much, you can now leave. They exited out of the room, and they had to walk down a long corridor. The actual experiment that was done by Barr then was to measure how long it took them to walk down that corridor. So the speed they walked down. Interestingly, those that had been exposed to the words that were more sort of to do with being old and lethargic and slow and those types of ones, they actually walked down the corridor notably slower than those that had been exposed to the more youthful words. And when asked, people at the end, did you walk up and down that corridor faster or slower than you think you would normally? People were not aware of any particular effect. So this was more of an unconscious effect that this anchoring effect had on individuals. Now, some really, really interesting experiments that have been done that just demonstrate the impact of anchors, of initial pieces of information, be they related or unrelated, be they conscious or unconscious in terms of our behaviours, but it's demonstrated this happens. And the reality is that most people, when they learn about these things, they go, okay, yeah, fair enough. Other people, they're influenced by these types of persuasive messaging and marketers and all of those types of things. I'm not. It doesn't affect me. This is another person who's impacted by it. And it's known as the third person effect, that it's, yeah, okay, I'll accept that, but it doesn't apply to me. It does apply to us. That's the blunt reality, whether we like to think of it or not. In part, it applies and happens to us. And why do we say it doesn't? Well, in part because some of this is subconscious. We're not aware of it or it's unconscious. Beyond this, none of us like to think of ourselves as being that easily swayed, even if that is the reality. So takeaway in this here is that there are lots of things that do affect our thinking, consciously and unconsciously. And it is important then just to appreciate that effect, because when we're designing software, we will want to think about aspects around cognitive load, other aspects around what information are we showing, aspects around how people will be thinking and reacting to this, and are they in a position where they can take on this particular task and other related ones. So we're not there to deceive people, we're not there to bring them around a certain way of thinking, but we are here to always think about what is the user's mental state, their cognitive state, and be mindful of that when we are designing our software. We want to take this into account through our design. Now, it's a really fascinating area, this, I believe. Hopefully you think so too. If you want to do a bit of further reading, I've got 3 sort of really, really good, easy reads, fantastic stuff in terms of finding a bit more. So one is a very famous book by Daniel Kahneman about thinking fast and slow. Other one about predictably irrational, about how if we think we are thinking in an irrational way, we actually do this quite predictably. And the final one then about nudging, about small effects that can have a disproportionately large impact in our decision making. So the next video after this, we're going to have a look at then how we see and make a little bit more of an in-depth into that.